So this session I will cover the numerical example of DBSCAN clustering. So this is the given data set, right, in the problem statement. So there are total 12 points given in the problem statement, and these 12 points are represented by the two features X and Y. You can assume this is the person's height and weight data set. So X is the height and Y is the weight, right? And this is the graphical representation of the data set, right? This graph shows the graphical representation of the data set, right? Represented on the XY space here. So here, unlike your K-means clustering, K is not mentioned in the problem statement, but two values are given in the problem statement, that is epsilon value and the minimum points are given. So here in the given problem statement, my epsilon value is 1.9 and minimum points are given 4. Right, so we'll one example with this example, right, numerical solution, we will discuss how this DBSCAN clustering algorithm helps to form the group of clusters. Now we don't know how many clusters will be in the solution, right? So that is not given here initially in the problem statement, right? So with the help of epsilon value and minimum points, we will form the clusters here. So first step is to obtain the distance matrix by using one of the distance measure, right? Either Euclidean distance, Manhattan distance. You can first find the distance matrix for the given data points. So this is the distance matrix for the given set of data points, 12 data points, right? So for example, distance between point P1 and P2 is 1.41. And distance between point P1 and P3 is 2.83 and so on. As you know how to calculate this distance matrix. So first step is calculate the distance matrix. Once you are ready with the distance matrix, right, you can find out here by considering the epsilon value and minimum points, you can find out the number of neighbors of a particular center point. So you will consider the center point for each and every point. So we will start with the first point P1. So in the first iteration, my P1 in the first step, my P1 will be the center point. Now check which other points are neighbor to the P1 point. So here the neighbor points are those points whose distance from this P1 is less than equal to 1.9. Right. So you can first check the horizontal and then go for the vertical, because P1 is the first point. Here only we will go the vertical scanning, right? So if you check here, P2 is at a distance 1.41 from the P1 point, right, which is satisfying my epsilon criteria, right? So the distance between P1 and P2 is less than 1.9. So P2 will be the closer of the P1, right, neighbor of the P1. Then P3, which is having distance 2.83. So we will not consider P3 as a neighbor for the P1, right, which is greater than 1.9. Again, P4 is not the neighbor, P5 is not the neighbor point, right? So only P10, P2, after P2, P10 is again having the distance which is less than epsilon value. So again, P10 we will consider in the P1 point, right? P1 cluster, right? Again, this P11 and P12 are not satisfying the criteria. So here we have obtained one group of points in a cluster by considering P1 as the center point, right? So this P1 covers these 3 points, P1, P2, and P10, right? Similarly, here calculate all the points. Those will come under the radius of 1.9 by considering P2 as the center point. So if we consider P2 point as the center point here, so here first check horizontally. So horizontally only P2 is here. Then we can check here vertically. So with P2 only P1 is there, right? P1 is having the distance less than 1.9. Then P10 is having the less than distance, right? For P2 is having only the P11 here. P3 also, P3 is having the distance less than 1.9 with the P2. Then here P11 is also having the distance less than here 1.9. So here we have formed the group of these 4 points, right, in the P2 at the center point in this group of P2, right? Similarly, check for the P3. So here if P3 we check horizontally, so here we are finding P2 is the closer to the P3, which is satisfying the epsilon criteria. Then check for vertically here. So this is my P3 column. So P4 is closer to the P3, which is satisfying the epsilon criteria. Only one point is there, that is P4. So for this P3 center point, we have find the neighbors P2 and P4. Then check for the P4. For P4, if we check horizontally, only we are getting P3 as a closer here. Then check here horizontal, vertical here, sorry, horizontal, we have find only P3 as a neighbor. Then vertical, we are find P5 is the neighbor for P4. So only P5 is the neighbor here, right? So again for P4, we have obtained these neighbors P3 and P5 within the radius of 1.9. Similarly, calculate for P5. So in the P5, if you check horizontally here, so we are getting here P4 as a neighbor, right? So that we have written here P4. Then check vertical here. So P6 is also one of the neighbor that we have written here P6. Then P7 is also one of the neighbor. Then P8 is also neighbor, which is satisfying the epsilon criteria. P7 and P8 we have written here in the group. So these are the 5 points we have obtained in this group of P5, right? Similarly, you can find out these close points to each and every point considering as a center. So for P6, we can find here P5 and P7 are the close points. Then for P7, P5 and P6 are the close point. For P8, P5 are close point by considering epsilon as a 1.9, right? For P9, only single point. For P10, again, these 2 points, P1 and P11. And for P11, these are the 5 points, right? And for P12, these are the 3 points. So once you have obtained this matrix, right, or all the groups, those are satisfying the criteria of the epsilon 1.9, check for the minimum number of points. Check for the minimum number of points. So out of this set of groups, right? So how many groups you have obtained here? 12 groups, definitely 12 groups, right? Or by considering each and every points as a center point. So check which group will be form as a cluster, right? So which points will be acts as the core points here. So check whether P1 will act as a core point. Here my criteria for minimum points is 4. So for P1, my number of points including P1 is only 3. So it is not satisfying the criteria of minimum 4. So P1 is not my core point. Then for P2, check how many points are there, right? So 1, 2, 3, 4. So definitely my P4 will be the core point that I have pointed here by the circle, because it is satisfying by the criteria of minimum points, right? My P3 is again having only 3 points. So P3 will not be my core point, right? Then P4 is not a core point, right? Not satisfying the criteria of minimum points. My P5 will act as a core point because number of points around this P5 is 5, right? P6 is again not the core point. P7 not a core point. P8 not core point. P9 also not core point. P10 is also not core point. Again here, if you check P11, P11 is having total 5 points, 4 points around it. So again, P11 will be acts as a core point. And again, P12 is not the core point. So we have scanned all these groups and found that only P2, P5 and P11 will be my core points. Now, if this 3, which one? My P2, then P5 and my P11 are only the core points. So remaining points will be acts as a noise point. Now in the next step, we will discuss whether these noise points can be converted into the border point or not. So we will check for the border point conditions. So here is the solution. So these points, those we have obtained in the previous slide, core points. These are the 2, 11 and 5 highlighted with the red color, right? So these 3 are the core points and remaining we have mentioned as a status noise point. Now, all remaining points are noise points. So check whether really they are a noise point or can be converted into the border point. So what is the definition of border point, right? So definitely the points are noise point when the number of points are less than 4 here for this example, right? So here for P1, now we know that P2 is the core point, right? There is no issue. Then P5 is the core point, and also my P11 is the core point. Now we will check for the other points. So first is the P1. So we will check whether P1 can be converted into the border point. So where is my P1 point here? So if you draw here the circle, so P1 is here, we are getting here the within the radius of 1.9, we are getting P2 and P10 within this circle of P1. So check one of the point in this circle is a core point or not. So in this group, my P2 is coming, right? And P2 is nothing but the core point. So P1 is can be converted into the border point, right? So my P1 is reachable to the P2 point, which is a core point, and that's why my P1 can be converted into the border point here, right? Similarly, now check for the P3 point. So here is the P3 group of points in the P3, right? So P2 and P4, again, my P2 is the core point in this group. So my P3 can be converted into the border point, right? My P3 is nothing but the border point. Then next check for the P4 point. My P4 point groups are P3 and P5, and out of this P5 is the core point, right? So definitely my P4 can be converted as a border point here, right? Then check for the P6 point. So P6 is having these 3 points, P5 and P7. Out of these two, P5 is the core point. So again, my P6 is also the border point. Then for P7, my P7 group includes P5 and P6. So out of these two, P5 is the core point, right? So again, my P7 can be the border point here, right? Then check for the P8. P8 only have only single point P5, right? So P5 is a core point. So definitely my P8 is also the border point. Now check for the P9. My P9 only includes one single point, which is the P12. Now check whether P12 is a core point. No, P12 is not the core point, and that's why my P9 is the noise point here. I hope students you are clear with this, because P9 neighbor is only one point P12, and which is not the core point, and that's why my P9 is the noise point here. Then P10, P1, P11. So out of these two, P11 is the core, and that's why P10 can be the border point here. Again, P10 is the border point, right? P11 is core point, and check for the P12. Neighbors of the P12 are P9 and P11. So P11 is my core point, and that's why my P12 is also the border point. So once you have obtained this solution, right? So only one point, which is the 9 point highlighted by here with the black color, is the noise point, right? Then by considering these groups here, core points, so we have obtained total 3 clusters. So first one is the P2, and it covers the 3 elements, P1, P3, and P11. So these are the points will come into the first cluster here, right? Including P2. Right, so this radius will be of what? This radius will be of 1.9, right? Similarly, second cluster that we have obtained here in the solution is P5. So around P5, there are P4, P6, P6, and P8. So second cluster that we have obtained here is this. And third cluster is a P11, around P11, which covers P2, then P10, then P12 points, right? So these are the 4 points which are covered by this group, right? So these are the 3 cluster we have obtained in this solution, and only one noise point we have found here, which we are excluded from the solution, right? Means my DBSCAN algorithm has identified this noise point, and that is not part of any cluster. So I hope students you are clear with how your DBSCAN algorithm is a robust algorithm and sensitive to the outliers, and it ignores the outliers while forming the clustering. Thank you. So these are the two reference books that you can refer here for this DBSCAN clustering, Data Mining and Concept by Hamber. So Data Mining Introductory and Advanced Topics by MH Donham, and also the machine learning book that is given in the syllabus. Thank you.